Hello students, good evening. Welcome to Wallah. Welcome to lecture series on theory of computation. Yesterday, first class of theory of computation lecture series is completed. Today is our second lecture, continuation of yesterday's class. So today is our lecture number 2 of the lecture series theory of computation. Is it my voice clear before going to start our session? Video and audio is clear. If you are anybody facing any problem, please reply me in chat. Reply me in chat box so that we can adjust if you are facing any problem of video quality or audio quality. Right? Is everything okay? Right? Can I proceed? Right. So yesterday we have seen what is theory of computation, meaning of the subject theory of computation, how it is useful for our branch of computer science. Theory of computation is mathematical study mainly used to describe what type of problems are solvable by computers, what type of problems are not solvable by computers. Okay. Right. So in before going to start this session, let us see what we studied in yesterday's class. If any new students join today, so that they don't feel any difficulty. Right. In our yesterday session, we have seen theory of computation subject topics. Topics we are going to cover in this subject. The topics we are going to cover here is regular language, context free language, context sensitive language, recursive enumerable language. And I explained you weightage of each topic. These are the topics generally we are studying in theory of computation subject. So weightage of this topic, first topic is 50%. 50% weightage. For this 20% weightage, this is 30% weightage. I told you theory of computation is highly scoring subject. We can score good marks in GATE examination. We don't get any difficult questions from this subject in the GATE examination. High weightage, we get more marks. Third one is, this is a base, this base of the subject is required to study compiler design subject. So compiler design, theory of computation together, 15 to 20 marks we can expect in the GATE examination. So these are the advantages of this subject. And then we studied in yesterday's session, we studied first topic, finite automata. We have seen some of the terminologies. What is the meaning of a language? What is the meaning of a language? What is the meaning of a string? What is alphabet? So all these terminologies meaning we have seen. Let me just recap yesterday's some of the terminologies. What is the language here? Language is nothing but any set of strings. Any set of strings called as language. So generally in our practical situations of computer science, we study C, C++, Java, these as languages. But in theory of computation, this is completely a mathematical study. So here our language looks like in this format. So we will call set of strings as language. What is that set nature? Any set of strings. Thank you. Okay students, keep on reply if you are having any doubts or any comments, you can reply on chat. Okay. Here there are 6 languages here. In this names of these languages also yesterday we have seen. So if anybody listen yesterday's class, can you tell me what is the name of this language L3? Yesterday we have given in yesterday's session. If anybody missed this, recording is available in our YouTube channel, Wallah English YouTube channel. You can watch those recordings. Right. So if any language is of this nature, any set of strings, this is called as empty language. This is empty language. What is the name of this language L6? Yesterday I have given the name for this language L6. The name of this language is complete language. Complete language. So today it seems some new students joined. That's why I'm just repeating what we discussed in yesterday's session. You can watch recordings as well. Just let me explain roughly briefly about this terminologies, then we can move on to today's topic. Right, this is complete language. The complete language also can be represented with sigma star. So these are the terminologies, are basic mathematical terminologies which are required to understand this subject. These things we studied in yesterday's session, and then we studied concept of finite automata. There are two types of finite automata: finite automata with output, finite automata without output. This without output concept we'll study in compilers, with output we'll study in circuit design. So whenever we say finite automata designing, so here in our syllabus of GATE, in first topic we have mainly two concepts: finite automata and regular languages. Our focus is now on finite automata. So to design finite automata, we need to understand designing of 5 techniques. Those techniques mentioned here: first one DFA, NFA, epsilon NFA, Mealy machine, Moore machine. So learning of finite automata is nothing but learning about these 5 techniques. How to construct finite automata by using these five things. If you know about that, that is the complete of our topic finite automata. That's why in our yesterday session we have started already learning about first topic, deterministic finite automata. So today also our discussion mostly goes on deterministic finite automata. So if anybody having difficulty, or if anybody not understand in yesterday's session, please read this definition once again. What is this deterministic finite automata? DFA. As per the definition, DFA is nothing but it is a finite automata in which from every state on every input symbol, every state, every input symbol, exactly one transition exists. In any finite automata, every state, every symbol, exactly one transition exists. That automata is known as deterministic finite automata. There are some confusions. So whenever we are studying this subject, especially this topic, deterministic finite automata, there are some diagrams looks like this. This is also finite automata, but is it DFA? Is it a deterministic finite automata? In order to we performed analysis on this type of automata in our yesterday session. If you want to understand, if you want to know clearly about how to analyze a given automata as deterministic finite automata or not, we need to study a 5-tuple definition of the DFA. 5-tuple definition. So if in any finite automata all these 5 things exist, we can call confidently that automata is a deterministic finite automata. What are these 5 things? Q is finite number of states, sigma input alphabet, Q0 initial state, only one initial state. Number of initial states in a given any finite automata is nothing but only one. F is set of final states. So how many final states allowed in a given DFA? Number of final states can be anything. 0 number of final states allowed because it is set of final states. Number of final states in a given DFA can be 0 number of final states, 1 final state, 2 final state, 3 final state, n number of final states also possible here. Then transition function. Transition function is nothing but given state, from the given state on the given input symbol exactly one transition should exist. What is meaning of transition? Edges. So if you want to say any automata is DFA, from every state on every input symbol there should be one transition. If transition is not there, not a DFA. More than one transition exists, not a DFA. So if all these 5 tuple present in any finite automata, then only it is DFA. If any one thing is missing, that is not a DFA. Like this we analyzed which is DFA, which is not DFA in yesterday's class in a very clearly with so many examples. So what is today's session? Today's session also focusing mainly on deterministic finite automata, but based on their languages. So in today's session, whenever if you see any DFA, in yesterday's class we have seen some interesting DFAs. In our yesterday's session we discussed this type of automata. Seems very bigger one, so many number of states are there. Whatever it may be, just by looking the automata, how to find whether it is DFA or not, those topics we discussed in yesterday's session. In today's session, if you find if it is DFA, in yesterday's class we have seen this example also, it is not DFA because there is a transition on 0 missing. If you add this transition, then only it can become into DFA. Till now all this the topics whatever is required to detect given automata as DFA or not we discussed. In today's session every DFA represents one language. In today's session what we are discussing is DFA, deterministic finite automata, is equal to one language. Whenever you say any automata, finite automata is deterministic finite automata, DFA, then the DFA represents one language. That means every DFA is equal to one language, every DFA recognizes one language, exactly one language. So this is our first question in the gate paper. In the gate paper mainly we will get 2 type of questions. He will give one DFA, what is the language accepted by that DFA? This is a common question, many times asked question in gate papers. The second type of question is he will give a language how many states are there in minimal DFA of this. So what we need to learn from this topic DFA is, if DFA is given, identification of language from the DFA, if language is given, construction of DFA from the language. So these 2 type of questions are very famous, many times asked questions in previous gate papers. That's why in our today's session we are mainly focusing on our first topic, how to recognize language if a DFA is given. So this is what our today's topic. Is it clear, students, till now? So what we are going to study in our today's topic? Detection of language from the given DFA. Right. Questions are most of these questions are previous gate questions, so we'll try to solve this. carefully. See, this is the question asked for 2 marks in one of the gate paper. Identify language accepted by given DFA. I told you, first of all, we'll check whether it is DFA or not. What is DFA? From every state on every symbol, transition should exist. That 5-tuple definition. So here, there are 3 states here. In this automata, there are 3 states. We have one initial state, that is Q0 is the initial state. Q2, double circle 1 is the final state. So this is clearly a DFA because from Q0, A transition exists, B transition exists. From Q1, A transition exists, B transition exists. Q2, A transition, B transition. Every state, every transition clearly exists. So this is DFA. Now the question is, if it is DFA, every DFA is equal to one language. DFA equal to one language. If it is equal to a language, what is the language accepted by this DFA? So this is the common question many times asked in gate papers. So to solve these type of questions, you need not to have the idea of regular expressions, regular language, those things knowledge is not required. We'll solve many questions of the gate paper just by using a trick called as elimination. So we will try to eliminate some options. Finally, remaining option is our answer. This trick works very well in gate paper, especially for the subject theory of computation. In theory of computation, finally by end of our lecture, the last lecture, most of the gate questions, almost 60 to 70% of the gate questions we can solve by using this trick. The name of this trick is called as elimination method or just elimination of options. Right. Now let us see how we'll eliminate options according to the given deterministic finite automata. Can we start? Before that, I'll give answer anyhow. Before that, the students, those who are watching this session, you please give your answer. This is the DFA. Options are like this. The option is saying the language accepted by this DFA is set of all strings. First one is starting with double B. Second one, set of all strings ending with double B. Third one is set of all strings contains at least 2 B's. Fourth one is none of this. See, the problem is the concept of this deterministic finite automata concept seems to be very easy. The moment you see, it seems very easy to solve, but tricky questions definitely will come in the gate paper. There is a high chance of getting negative marking. That's why we have to solve questions carefully. Almost options looks like same. So elimination of options carefully is important thing, and identifying our correct answer is very important. So concept seems to be easier, but solving questions is very tricky things. So questions also a bit tricky here from this topic. So we'll try to, this is a gate question. So what is your answer? Some students are saying A. Any other answers? So there is a DFA here, 3 states DFA. What is the language of this? In the options he is saying option A, set of all string starting with double B. Option B, set of all strings ending with double B. Option C, set of all strings. The language accepted by this DFA is set of all string contains at least 2 B's, minimum 2 B's. Option D, none of this. So what will be our correct answer? What is the right answer for this? Right. So in the chart box I am observing A or some people B. Okay. Anyhow, let me explain how to solve this. Try to eliminate from options. Let us take the option A. Whether it is correct option or not, we will see. What is saying? The language accepted by this DFA is set of all strings starting with double B. If the string is starting with double B, then only such type of strings only accepting. That is what the meaning of option A. But see this, if I take any string of this nature, double A, double B, it is not starting with double B, but accepted by this automata. What is acceptance? By reading that string, automata has to reach to final state. See here, by reading double A, double B, starting from the initial state, 1A, one more A, reaching final state, this string is accepted. So the type of strings accepted by this automata not having this condition, starting with double B, not having this condition, that's why A is not the answer. A is not the correct answer here, because the type of strings accepted here are which are not starting with double B. Right. Come to the option B. What is saying in the option B? The type of strings accepted by this automata is ending with double B type only. That is what the B option meaning. Set of all strings ending with double B, those type of strings only accepted. That's what he is saying in the option B. Is it true? Let us check. I'll take one string as double B, double A, which is not starting with double B, but accepted by this automata. Check it out. If starting from the initial state, 1B, one more B, 2A's. This is accepted. This string is not belongs to option B. This is ending with double A, option B is ending with double B. The strings not belongs to option B also accepted means this automata, this option are not same. So B is also not our answer. Because we want equality. If you say option A is equal, the strings accepted by this automata, strings generated by this condition should be same, which are not same, that's why I am eliminating A. In a similar way, if you want to say B is our answer, strings accepted by this automata, strings generated by this condition should be same. But see, this is the string accepted by this automata, but this string not satisfying condition of option B. So this is also wrong. Now come to the C. Most of the students will think C is the right answer, but C is also not the correct answer. I observed in so many batches. So from past 15 years I am teaching this subject. So in every batch, students generally will do mistake while selecting option C. What is C option here? So option C, according to the option C, the meaning is language accepted by this automata is set of all strings contain at least 2 B's. At least 2 B's means if minimum 2 B's are there, accepting. That is what the option C is saying. Whether it is correct or not, let us check. At least 2 B's means, now I am taking one string. Is it having at least 2 B's? Yes. Whatever is the option C contains at least 2 B's. According to this condition, this is valid string. According to option C, this is valid string because minimum 2 B's are there here. 3 B's I am taking. So if C is the correct answer, because this string belongs to option C, if C is the correct answer, every string of this option C should be accepted by this automata. If C is the correct answer, this should be accepted by this automata. Let us check whether it is accepting or not. BA, BA, BA. For one BA, like this, again BA, like this, again BA, like this. So if we give any number of BA followed by B followed by A like this, the automata keep on non-final states. It's not reaching to the final state. So if the string is not accepted, the string belongs to the option C, not accepted by this automata. This is also not the right answer. So the correct answer for this is D. Don't try to analyze the language at this stage, because we are in the initial stages of DFA. How to analyze the language, exactly equal language also I'll teach you. But at this stage, how to get the correct answers from the DFA, because these type of questions generally we are getting in gate papers. Those, I think in the last year paper also we have such type of question. He has given on automata, and which of the following is a language. So the best way, if DFA or any finite automata is given, to detect the language, the best approach, best trick is elimination. Eliminate from options, will get the answers exactly, almost correctly. Correct answer will get in the elimination method. So this is the way. That's why if you want to know correct answers from given DFA, the best trick is elimination. Eliminate from options. So by using this trick, the correct answer for this question is D. None of this. All these are wrong answers. All right. So in a similar way, there are so many questions in gate papers. We'll see some more questions. Any doubt in this question? If anybody having doubt related to any option, you can ask me. I'll give time. The students who are in live, if they are having any doubts regarding this question, I can explain you. Most of the time, most of the students know, many times they will confuse about C option. The confusion is nothing but, take this type of strings. This string clearly belongs to option C, the language of option C, but it is not accepted by the given automata. So if it is not accepted by given automata, we cannot call it as the correct option. Right. A similar way, we got one more question in one year gate paper. First, find out whether it is a valid DFA or not. Is it valid DFA or not? DFA means from every state, every symbol, transition exists or not. Here 3 states are there. I can name these states as well. Q0 state, then it will be easy for you. Three states, Q0, Q1, Q2. To say DFA, every state, every symbol, transition should exist. So Q0 state, 0 transition, 1 transition. Q1 state, 0 transition, 1 transition. Q2 state, 0 transition. On 1 we have a transition like this. So this is clearly DFA. Good evening. So try to give the answer. I told you to answer this type of questions, elimination is best trick. We can get answers correctly if we use the elimination trick. Identify language accepted by following DFA. Set of all strings starting with 00, first option. Set of all strings having substring 00, ending with 0, none of this. Which option is the right one out of this? So option C is ending with 0, starting with 00, substring 00, D none. Right. So elimination. What is the language accepted by this DFA? Eliminate from options. The language of this DFA, whatever the option you are saying correct option, both should be equal. So some students in the chart box, they are changing from ending with 00 to ending with 0. Ending with 00 is a different language, ending with 0 is a different language. If I say ending with 00, that language goes different. Ending with single 0, different. The minimum strings varies. The language minimum strings varies. All these minute differences language will come definitely in options of gate paper. That's why if you don't know what is a ending with 0 language, how it looks like, ending with 00 language, how it looks like, your option completely goes wrong. So very good, very good. Try to give answers. Some people are saying B, good attempt. Some people are saying C, good attempt. So the problem with gate questions are, you think that your answer is correct, but mostly that is not correct. There is a high chance of getting negative marking. So we need to practice very clearly. Right. So 3-state DFA, it is clearly DFA. Even if you don't know what is the language, go from finite automata to language detection. To solve this type of questions, the best trick is eliminate from options. Elimination is the easiest way of solving this type of questions. Right. So what is the first option here? I am solving this. Match with your answers. How I am analyzing this question, how I am solving, try to understand, then it becomes easy for you to solve questions by your own. Option A. First try to generate the strings of option A. Strings of option A, give to this automata. If this is accepting all these strings, then A is the right answer, this way. So what is the condition of option A? Set of all strings starting with 00. Starting with 00. That means starting with 00 strings only accepted by this automata. That is what his meaning. So if I give this string 100, is this string belongs to this language? First of all, 100, is it belongs to this? Starting with 00 is required. It is not belongs to this. If A is the right answer, this string should be rejected. It is not starting with 00, that's why it has to be rejected if A is the right answer. But what happens, even though string is not starting with 00, this automata clearly accepting. Even if the string is not, see, 00 accepting, 100, 100 accepted by this automata. That means to accept the strings starting with 00 is not required condition. So this is not our condition, A is gone. What we need to see, what we need to observe, what type of strings accepted by this automata. To accept the string, what is the condition required by this automata? Come to the option B, substring 00. Try to generate the strings of this option B. Substring 00 in this language, if you apply this condition, the strings will be like this. Right. One substring means consecutive 20 should be there. The meaning of this language is substring 00 means consecutive 20 should be there. Those two zeros can be in the starting, in the middle, in the ending, anywhere. So this is one of the valid thing. 001 is also valid. These type of strings. According to option B, these are the possible strings present in that language. So if all these type of strings are accepted, then only B will be right answer. But 00, check from the automata. 00 accepted. 2 zeros from the initial state. If we give 2 zeros going to final state, accepted, 2 zeros accepted. Every string should be accepted, then only B will be the right answer. 100 accepted. Come to 001. Starting from the initial state, first 0, second 0, 1, rejecting. This is non-final state. So B is not the right answer. Some people are saying option B. B is not the right answer because substring 00, the language accepted by this automata means if 00 presents anywhere, it has to accept, whether it can be starting, whether it can be ending, anywhere. But 00 presents in the starting, this is clearly rejecting. First 2 zeros followed by single 1 comes, reaching non-final state. So substring 00 is not the language accepted by this DFA. Come to the option C. Many people are confusing about option C. What is option C here? Ending with 0. Many students are saying that language accepted by this automata is ending with 0. Is it true? First, let us try to generate strings possible according to this condition. What type of strings possible according to option C? What is this? First minimum length string 0. Ending with 0 means 0 is valid string, 1 0 is valid, 2 zeros valid, and so on, like this. The strings of this language is this way, and so many strings are there. This is an infinite language. C is the right answer only if all these strings are accepted by this automata. If all these strings are accepted here, then C is the right answer. But check, is it 0 accepted by this? Starting from the initial state, if we give 0, automata reaching Q1 only. It is a non-final state. So 0 rejected. Because all these strings are present in ending with 0 language. To say C is the right answer, all these strings should be accepted by this automata. Is it happening here? 1 0 rejecting, 00 okay, anyhow, at least one string also rejected. This is not the language equal to this automata. C is also wrong answer. Is it clear? I observed in many batches, most of the time, most of the students, they have given option C as the answer. But clearly C is not the answer because of these reasons. I am explaining reason. This is not ending with 0. So some people are saying ending with 00. So whatever it may be, we will see that the language, exactly how to identify language from this in the coming classes. But here anyhow none of this option is there. So the correct answer for this is any of these languages not equal to this. Starting with 00 not equal to this automata. Substring 00, this language is also not equal with this automata. Ending with single 0, this language is also not equal with this automata. There is some other language we don't know at this stage. That's why here clearly D. How these questions looks like? Any difficulty? These are gate questions. Previous question is also gate question. This is also gate question. That to 2-mark question gate papers. In last year paper also we have this type of questions. These are common questions. Most of the times we got in gate paper in the previous papers. So the way of solving this question is this way. Take small violating strings, apply to this. If those strings are not accepted by the given automata, then that is not the option equal to this automata. Right. Then we will move to similar question. So these are the two questions where generally students will confuse. They will try to give wrong option. So this is one gate question. This is also one of the gate question. Most of the student did mistake in these two questions in the previous papers. Right. So this is one more question. And don't find always none of the above is there. That will be the right answer. Like this, you don't mark. There is no trick like that. The trick is elimination. Eliminate from options. If the option is suitable for your language, that is your answer. What is the language accepted by? Identify language accepted by this DFA. First option a power n b power m, n comma m greater than or equal to 1. Second one a power n b power m, n value starts from 1, m value starts from 0. Third one a power n b power m, n m both starts from 0. Both starts from 0. What will be the minimum length string? This is 0, a length is 0, b length is 0. The minimum length possible here is epsilon. Epsilon followed by so many other. Right. Any options from anybody? First of all, is it DFA? There are 3 states. Here also there are 3 states. Q1 is the final state. This is dead state. Dead state is also non-final state. Just a name like this. You don't confuse with this. I am asking about options, not asking about any regular expression, which is the right answer. If you are able to solve, I can give poll as well. Giving poll, right. Answer in poll. Only one answer is right. Okay. So eliminate from options. DFA to language. Best way is eliminate from options. So what is the first one? What is the minimum string accepted by this automata? To solve this type of questions, already told you, DFA language, options language, if it is same, that answer will be correct. What is the, try to generate, let us try to generate some strings from this DFA. The minimum string accepted is B. Starting from the initial state by reading B, reaching final state. Then we have double B and so on, so many other. So try to match this language from the given options. Okay, right. Option A. What is the minimum string from option A? A, B, followed by so many. The minimum strings of the automata, minimum strings of the language, if they are same, then only that option can be equal. But here minimum string of this automata is B, minimum string of this language is, option A language is AB. These two are not equal. A is gone. A is not our answer because the minimum string here is B, minimum string here is AB. If you want to say both are equal, minimum string should be equal. If they are not equal, that is not our right answer. Come to the option B. It's very easy. Now we are solving so many questions. Till now we solved almost 2 questions. So it is those questions are somewhat tricky. This is very easy. We don't get much time. Can you tell me what is the minimum string we can generate from option B? M value 0. Whenever M value 0, this becomes epsilon. The minimum string possible here is A. N starts from 1. Then remaining. The one length string possible from option B is symbol A. But the one length string we can generate from given one length string accepted by given automata is B. Both are not same, then not equal. One string sufficient to say not. Elimination is, that is why elimination, why it is a very famous one is, famous technique is one string sufficient to say no. Really in mathematics, if you want to prove anything is yes. So many cases you have to show how it is equal like that. If you want to say no, at least one thing is sufficient, one string. So if you want to say these two are not equal, one string sufficient. So elimination, we can solve the questions very easily because of, if you want to say they are not equal, this option is not equal, just one string is sufficient. So here the minimum string is A, minimum string is B, both are not same, B is also not the right answer. Come to the option C. What is the minimum string possible from option C? N value starts from 0, M value starts from 0. If both are 0, this is 0 times, this is 0 times. What is the minimum string here? Epsilon. But the language accepted by this automata is B. To accept epsilon, initial state and final state should be same. Whenever initial and final states are same, then only epsilon is accepted. But here epsilon cannot be accepted by this. C is also not our answer. Is it clear this question? Anybody having doubts? Students, any doubts on this question? Questions are simple, very easy questions, but generally students will confuse about selecting correct answer. Right. I am giving the similar question, almost the same question. I am expecting correct answer from all of you. Right. Here also 3 states are there, Q0, Q1, dead state. What is the language accepted by this DFA? What type of language accepted by this DFA? Now I think we can solve questions in seconds. Okay, if we are able to give regular expression, tell them in language format, because no guarantee always he will give options in regular expressions. Sometimes options can be in regular expressions, sometimes like this in the language format. The language can be shown in this way, or just some sentence you will write, or sometimes in regular expressions. Elimination, it's very easy. Now we can solve the question in seconds if we use elimination. First, to solve this type of questions, what type of strings accepted by this DFA? Recognize some strings. Just elimination, no. So in order to mismatch, we have to generate some strings. What is the minimum string accepted by this? Here Q0 is also final state, Q1 is also final state. Q0 is initial as well as final, Q1 is double circle, so it is final. Epsilon accepted, A accepted, B accepted. From the initial, if we give A, going to final. From the initial, if we give only B, going to final. What is the minimum string generated by option A? This is AB. A is gone. What is the minimum string generated by option B? M value 0. So minimum string generated by option B is A. Minimum string generated by this automata is epsilon. So it is not there epsilon in option A. A is gone. Epsilon is not there in option B. This is also gone. See here. Can we generate epsilon from here? Yes. Epsilon. If I take B value as 0, only A is possible. Epsilon possible. Only A is possible. Only B is possible. So the correct answer for this question is C. Any confusion? C is the right answer. Any number of A's followed by any number of B's. So now, if any DFA is given, detection of language, solving these type of questions will be, the time required to solve this type of question will be in seconds or 1 or 2 minutes maximum. Give correct answer for this. Number of A's, hash meaning is, this is a clearly DFA from the state A transition, B transition, from the state A transition, B transition, from the state A transition, B transition, from the state A transition, B transition. Hash meaning is number of A's even, option A, number of A's even, number of B's even, number of A's odd, number of B's even, number of A's odd and number of B's odd, number of A's even and number of B's odd. Number of A's divisible by, that is different. Odd and even are different. So anyhow, what are the exact languages equal to this DFA? Those we will study in coming classes. Here you try to identify, because this type of concepts you makes your DFA concept more clear. You can understand the concept of DFA in a more clear way. Right. So for this, the question actually, if you want to recognize its language, takes lot of time. Definitely minimum 2 minutes, 3 minutes it requires. If you want to recognize its language, otherwise some people are previously showing regular expression. Now tell me what is the regular expression for this. It takes lot of time, easily 5 minutes it requires. But if you eliminate from options, becomes very easy. That is the advantage of this method. The regular expression method, you can generate regular expression from this DFA. Take the concept requires lot of time, but we have to solve questions easily in gate paper. So the easiest way is, what is the minimum string accepted by this? Starting from initial state, if we read B, that is accepting. Starting from initial state, if you read B, that is accepted. So the minimum string accepted by this automata is B. So where is that in these options? We'll find. What is the minimum string according to option A? A7, B7. A7 means epsilon, B7 means epsilon. So the minimum string accepted according to option A, epsilon. Option A minimum string epsilon. Our automata accepted minimum string is B. This is gone. Yes, dense method, all methods, if you want to construct regular expression, takes a lot of time. Come to the option B. Can you tell me what is the minimum string according to option B? Whenever it is even, you can assume this is 0 times. A is odd, 1 time. Minimum string according to option B is A. First we will generate the minimum strings, then it will be easy for you. A is odd, B is odd. So it can be AB string or it can be BA string. Minimum string according to option D. A is even, this is 0 time, B is odd. Minimum string is B. B is not there. Option A eliminated. B is not there in option B. Option B is eliminated. What is the minimum string of option C? AB or BA. So the minimum string accepted by this automata is B, which is not there here. This is also not our answer. So D is our answer. So the language accepted by this automata is number of A's even and number of B's odd. Finding that language directly is difficult concept, time taking process. It's not impossible, time taking process. But elimination from options, this question is given in gate paper. Long back, this type of question also given. But so many methods are there. We can write the language strings, we can identify, you can construct regular expression by using different methods. That also it is a time taking one. But elimination, if you see, easily in seconds we can answer the question. Is it clear, students? How is this trick elimination to solve especially this type of questions? So recording is available. Gokul, recording is available. You can watch a number of times. Still confusing? Ask me in tomorrow session. Right. In seconds I am expecting answer from you. Similar question. I changed the final state. Now I have 4 states here. Guys, I am expecting answer in seconds. What is the right answer for this? By elimination. Very good, very good, very good. This is the way of solving these questions. This is a DFA, which is the right answer. A7, B7, A sort, B sort, A sort, B7, A7, B sort. Take the minimum string of this. Take the minimum string of this. Match. What is the minimum string of this? Initial and final same. Whenever initial and final same, epsilon is the minimum string. Minimum string of this is epsilon. Generate minimum strings from these options. A even, B even. Minimum string epsilon. A odd, B odd. Minimum string AB or BA. A is odd, B is even. Even case you can take 0 number of times. Odd means 1 time. Minimum string A. I am taking minimum strings because language means infinite strings are there. So minimum string is enough here. A is even 0 times, B is odd 1 time. So minimum string of option A is epsilon, minimum string of option B is A, minimum string of option C is these two strings, minimum string of option D B. What is the minimum string of our automata? Epsilon. Where it presents? Option A. Directly A is the answer. Where is the confusion? Clear? Elimination. 𝐂𝐤𝐬 concept. It's very easy. Match the strings, eliminate. That's right. Now I am expecting, here it is exactly 2, seems covered with this digital board. The automata seems to be bigger, but more than 1 minute time is not required to solve this question. This is also a gate question. Use elimination trick. 1 minute is more than sufficient to solve this question. I am expecting right answer from everyone. Right. Try to solve this question. Give me answer. This is clearly valid DFA. What is the language accepted by this DFA? Eliminate from options. Take option A, valid or not. Option B, valid or not. Option C, valid or not. If all are valid, any one of this is valid, okay. Otherwise, this. These are our classes. How our class is going here is, we will solve the gate questions by using some tricks in seconds or 1 or 2 minutes, maximum 2 minutes. If you use traditional methods, no generating regular expressions or writing something language, it takes lot of time. That is not the gate approach. If you are preparing really for gate examination, like this, all short tricks you have to use to solve questions. Those things we are going to learn in our classes. My focus is mainly for gate point of view. How to solve the questions for gate 2025 in an easier way. So here according to students, attracting option seems to be A. According to students, I am saying. Because many are saying A, that's why attracting seems A is attracting option. That is not my answer. I'll explain, then I'll give my answer. Shall I start explaining? I think 2 minutes time is given to you. So I hope all of you are given answers. Right. Somebody changing from option A to option C, somebody changing from option B to option D. Okay, you can take your own time. This is the problem of gate questions. All options are seems to be matching to your answer, but only one answer is mostly correct. Right. So let me explain. Option A, elimination. The language accepted by this DFA. Some students, the moment they see this DFA, they'll get scared. So this is this much bigger. How to solve the question? Big questions very easy to solve. Whenever you get bigger questions, lengthy questions, feel happy because there are some tricks. The way of solving that question becomes very easy. Right. Length of the string at least 6. What is option A? He is saying the language accepted by this string, this DFA is length of the string at least 6. At least 6 length it is accepting. That is what he is saying here. Forget about date states and all this. That is the simple names. Just if you know what is final state, what is non-final state, we can manage the show. We can solve the questions. So date states and all this not required here. I'll explain in coming classes what is date state, what type of states are not date states. Come to the option A. Length of the string at least 6 means if minimum 6 length is there, such type of all strings accepted. That is what the meaning of option A. According to option A, any 6 or more length string is accepted. Let us see. I'll take according to option A, I am selecting one string as 7 zeros. 7 zeros. 7 zeros is clearly valid string of option A. Length of the string at least 6 means 7 zeros also present in this language. If A is the right answer, this string should be accepted by this. If I say A is the right answer, all these strings should be accepted by this automata. So this also should be accepted by this. Let us check it out whether it is accepted or not. 7 zeros, 1, 2, 3, 4, 5, 6, 7. This is the last one is non-final. Here we have only one final state. This is the final state of this automata. This is the initial state. If any string reaches final, then that only accepted. But here 7 zeros, the automata falling into non-final, 7 zeros rejected. If 7 zeros rejected, how can I say any at least 6 length accepted? So A is clearly wrong option. At least 6 length is not the condition of strings accepted by this automata, because I have selected a string which is violating this condition. If A is the answer, this string should be accepted. Not accepting, A is gone. Come to the B. What is option B? The option B, number of zeros exactly 4. Number of ones at least 3. If the strings of this nature, then only accepted. Okay. I'll take other than this. What happens, I'll see. 4 zeros, 2 ones I am taking. The selection of strings is the main thing here. That we will get by practice. What is option B? Option B is saying if exactly 4 zeros present and at least 3 ones present in your string, then only it is accepting. But if according to B, what is the nature of the string? This string should be rejected. If I assume B is my answer, this string is not satisfying option B condition. But see what happens in the automata. 4 zeros, 2 ones clearly accepted. So even if the condition of option B not present, also accepted. That means Whatever the condition is mentioned in option B, that is not the right condition. So B is also not our answer. Very easy to see this nature of this automata. Starting from initial, take any path. We will try to generalize this. So just for your understanding, I am explaining this, but it's very easy. Starting from initial, take any path. 4 zeros, minimum 2 ones. 4 zeros, exactly 4 zeros, minimum 2 ones. Take any path. Take this path. Take this path. Exactly 4 zeros, minimum 2 ones. Take any path. Exactly 4 zeros, minimum 2 ones. So the language accepted by this auto, take any path. Exactly 4 zeros, minimum 2 ones is the type of string accepted by this. Now option B, what is saying? At least 2 ones. That is the problem. At least 3 ones is saying in option B. That is the problem. What is option C? At least 4 zeros. Exactly 2 ones. Where it is? Exactly 2 ones is not the condition. Minimum 2 ones required. After that, any number of ones. That's why C is also not our answer. Option D. D is the right answer. So what is the language accepted by this one? Tell me. I think now we can, even the automata seems very bigger, we can easily analyze its language. Can you, some of you tell me what is the language of this? What is the language of this? Number of zeros, exactly 4, and number of ones, at least 2. Number of zeros, take any path from initial to final, exactly 4 zeros, minimum 2 ones. Like this. It is easy to solve. Even if you are unable to recognize this, eliminate from options, then here the suitable option is D. Okay. So this is the way we can solve all our questions related to this topic. So in today's session, we studied how to recognize language from the DFA. That is mainly how to identify what is a suitable answer from the given DFA, suitable language from the given DFA. So exactly, number of zeros exactly 4, number of ones at least 2. Think same thing I have written here. Number of ones at least 2, number of zeros exactly 4. Okay. Okay guys, that's all about this session. Thank you all. Every day we are discussing theory of computation lecture series at 8 p.m. So tomorrow also we will continue this session. Same concepts of deterministic finite automata and some non-deterministic finite automata concepts. Okay. Thank you. Bye bye. See you in tomorrow's session.